trigonometry, we sometimes expected to write one angle in terms of a letter or another angle. In this question, if sine 15 degrees is equal to p, determine the following in terms of p. So what they're asking me to do is any angle that I'm working with, I'm going to try and write it or reduce it to 15 degrees. In the first example, we get sine 165 degrees. Now, I just want to have a look at the cast diagram to see where that fits in. Now, 165 degrees is in the second quadrant, and the rule in the second quadrant is 180 degrees minus theta. And it just so happens that 180 degrees minus 15 degrees gives me 165 degrees. Now, in the second quadrant, sine is positive, so I don't need to write the 180 minus anymore. I can reduce it to sine 15 degrees, which is positive, and sine 15 degrees is p. So sine 165 degrees I can rewrite as just p. In the second example, we get sine 345 degrees. Now, 345 degrees lies in the fourth quadrant. And in the fourth quadrant, the rule is 360 minus theta. And it just so happens that 360 minus 15 degrees gives me 345 degrees. Now, in the fourth quadrant, sine is negative, so I can reduce that angle to minus sine 15 degrees. Sine 15 is p, so I can simplify that to minus p. In example C, we want to know sine of minus 15 degrees. Now, remember the lesson from negative angles. Minus 15 degrees will be measured down into the fourth quadrant, where sine is negative. So negative sine 15 degrees can be rewritten as negative p. Sine 375 degrees. Now that angle is greater than 360. So that's all the way back in the first quadrant, because I can rewrite 375 degrees as 360 degrees plus 15. Now, in the first quadrant, all my trig functions give me positive answers, so I can reduce that angle to sine 15 degrees, which is just p. Cos 75 degrees. Now, my function has changed, but I need to remember 75 degrees lies in the first quadrant, and I have another rule in the first quadrant, and that is this 90 degrees minus theta. So I can rewrite 75 degrees as 90 minus 15 degrees. But we need to remember, if we're using a 90 minus rule, the function must change. So cos changes to sine 15 degrees, which is p. The last two questions we're going to have a look at is if I'm given a different trig function but the same angle. So cos 15, and we're going to look at tan 15 just now. And because I can't use my normal reduction methods because the function is different, I need to make a slightly different plan. Now, we have got an identity that we can use. Remember that sine squared theta plus cos squared theta is 1. Theta can be any angle. In other words, sine squared 15 degrees plus cos squared 15 degrees is also 1. And if I rearrange that, I want to try and get cos 15 on its own. So I can take sine squared 15 to the other side, and if sine 15 is p, I can replace sine squared 15 with p squared. So cos squared 15 degrees is 1 minus p squared. And if I want cos 15 on its own, I can square root both sides. Now, I'm not allowed to square root each of those individually. I have to keep it as the square root of both. So that is your final answer. There's another method that you can use if you prefer. If we go back to the fact that sine 15 is equal to p, I can rewrite that slightly differently. I can rewrite it that sine 15 degrees is p over 1. I'm not changing anything, but if I look at it in that format, I've got a fraction, and I know the definition for sine is y over r, which means I have a y value of p and an r value of 1. And I can create a little Pythagoras question with it. So 15 degrees is an angle in the first quadrant. I know that my p value goes in place of y, and my r value is 1. And we can then use Pythagoras to calculate the x value. Now, why do we need to calculate the x value? Because the definition of cos is x over r. So x squared plus p squared is 1 squared, which means if I take p squared to the other side, x squared will be 1 minus p squared. And if I square root both sides, I get that x is equal to the square root of 1 minus p squared. The definition then for cos 15 is x over r. My x value is my square root and my r value is 1, which can be simplified to the square root of 1 minus p squared. Both methods give me exactly the same answer. You can choose which method you would like to use. The other one I want to discuss is tan 15 degrees. If you prefer to work with your identities, remember that tan 15 I can rewrite as sine 15 over cos 15. Sine 15 we were given as p, and cos 15 is the square root of 1 minus p squared. So tan 15 I can rewrite as p over the square root of 1 minus p squared. Alternatively, if you prefer to work with the sketch, the definition for tan 15 degrees is y over x. We've got our y value from the sketch and the x value we calculated. So rewrite it as p over the square root of 1 minus p squared.
Thanks for watching Max Maths. If you liked what you saw, please like, share and subscribe.